class 12 ncert. The question is, discuss the continuity of the function f where f is defined by f of x is equals to 3 if 0 less than or equals to x less than or equals to 1, 4 if 1 less than x less than 3, 5 if 3 less than or equals to x less than or equal to 10. So here we need to find the continuity of the functions. How we check? First we check the continuity for different values of x. How we find that different values of x means, check the question. The function from 0 less than or equals to x less than or equal to 1. The first one is 0 less than or equals to x less than or equal to 1. Here if you observe, this 1 is continued. Here the 1 is continuous from in the first case and the second case also. Now see, here we have the 1 and again 1 repeated. And again, here we have 3, here also we have 3. Means 1 is 2 times, 3 is 2 times. So I will split like 0 less than or equals to x less than 1, one case, and x is equals to 1, another case. Next, 1 less than x less than 3. Next, third case. Next, here I will take x is equals to 3. Here I have is equals to. So we take here x is equals to 3, fourth case. And last case is 3 less than or equals to x less than or equals to 10. So 5 cases are available. So next we started for the first case when 0 less than x less than 1. 0 less than or is equals to x less than 1. At this time, what is the function? 0 less than or equals to x less than 1. The function is 3. Next, the second case is x is equals to 1 case. So at 1 x is equals to 1, we will write this formula. LHL is equals to RHL is equals to f of 1. Then LHL is limit x tends to 1 minus f of x. And we can replace 1 minus as h tends to 0. F of x is replaced by 1 minus h. Next, LHL is limit h tends to 0. 1 minus, the function is 1 minus means less than of 1. So less than of 1, the function is x is less than 1. Here we have x less than 1. At that time, the function is 3. So I will write here the function 3. 3 is constant number. Then go for RHL. Here RHL is limit x tends to 1 plus f of x. Limit h tends to 0. We'll start with 0. F of x is replaced by 1 plus h. Limit h tends to 0. Now 1 plus means more than 1. More than 1, the function is 4 at that time. So I will write the function is 4. If we observe, if we compare LHL and RHL, both are not equals. So f is not continuous. Thus, f is not continuous at this case. Next case 3. What is the case 3? Case 3, when 1 less than x less than 3. This is the case 3. So at this case, what is the function? The function is 4. So f of x is equals to 4. This is constant. Therefore, f is continuous. Therefore, f is continuous. Next case. Case 4. Case 4 is when x is equals to 3. Again is equal to k. Means how can we write LHL is equals to RHL is equals to f of 3. How can you write LHL of 3? A limit x tends to 3 minus f of x, that is equals to limit h tends to 0, f of x is replaced by 3 minus h. So x is replaced by 3 minus h. Now write limit h tends to 0. 3 minus, what is the function when it is 3 minus? Means less than of 3. Less than of 3, the function is 4. So we will write here 4. Directly take number. Why? Because there is no h. If there is h, then we will write h value here. There is no h. We can directly take 4. So that is RHL. That is LHL. Now write RHL. RHL is equals to limit x tends to 3 plus f of x. So this is RHL. Now I want to start from 0. H tends to 0. F of x is replaced by 3 plus h. Now this value more than h. 3 plus means greater than 3. Greater than 3. 3, here we get the function. When it is greater than 3, the function is 5. So I will write here function 5. So if you observe, LHL is 4, RHL is 5. LHL not equals, therefore LHL not equals to RHL. F is not continuous. So at this case, F is not continuous. Next, fifth case. So we will find the fifth case. Case 5. What is the fifth case? When 3 less than x less than or equals to 10. So when 3 less than x less than or equals to 10. So this is the fifth case. At this case, what is the function? So at this case, the function is 5. This is constant. Therefore, f is continuous. The final conclusion. How can we write this conclusion? Thus, f is continuous for all x belongs to R, except at what cases it is discontinuity. It is discontinuous. Check this. First case it is continuous. Second case not continuous. Means what is the second case? 1. X is equals to 1 case. So except 1. Next go for the third case. Third case is continuous. And fourth case. Fourth case is also not continuous. What is the fourth case? When x is equal to 3. So the function is discontinuous at 1, 3. So f is continuous for all real numbers except 1, 3. This is the solution. Next, 15th question. The 15th question is, so same, we discussed the continuity of the function. F is defined by, the function is defined by f of x is equals to 2x if x less than 0. Next 0 if 0 less than or equals to x less than or equals to 1. Next 4x if x greater than 1. This is the function. Now we will check continuity for different values of x. So we check continuity for different values of x. So that is the values of x, or we will write the values of x when the first case. Observe the given question. So first case we have x less than 0. Second case, here 0 repeated. So x is equal to 0 we will take. Here we have equal, that's why we take x is equal to 0. Then one more case is 0 less than x less than or equals to 1. Another case is x greater than 1. So we will write these cases one by one. First one is x less than 0. X less than 0, first case. Second case, when x, here x is equals to 0 is there and this 0 repeated. So x is equals to 0 case. Third case, when is equals to over, completed. Now 0 less than x less than or equals to 1. 0 less than x less than or equals to 1. Next, last case, x greater than 1. So here we have 1 also again. So when x is equals to 1, one case. Another one is when x greater than 1. So x is equal to 1 case completed, x greater than 1 case completed. So I will take x is equals to 1 case. I will begin with the first case. The first case is x less than 0. So we will find the first case. Case 1, when x less than 0. When x less than 0, what is the function at that time? The function is 2x. So f of x is equals to 2x. So this is constant. This is constant function. Sorry, this is polynomial. Sorry. This is polynomial function. Therefore, f is continuous. So this is polynomial function and f is continuous. Next, case 2. Case 2, when x is equals to 0. Case 2 is x is equals to 0. How can we write equals? When it comes, we will write LHL is equals to RHL is equals to f of 0. How we write the LHL? Limit x tends to 0 minus f of x is equals to. So here I will start from, actually it is 0 minus. I will start from 0. So limit h tends to 0 f of 0 minus h. Now 0 minus, what is the function at this time? Limit h tends to 0. So 0 minus means less than of 0. Less than 0, when the function is less than 0, at that time the function is 2x. So here we'll write 2x. 2x means what? 0 minus h. Now write the h value here. So we'll get 0 minus 0 is 0 only. Next case is RHL. In this only we will find next RHL. RHL is equals to limit x tends to 0 plus f of x. Now I will start from 0. H tends to 0. F of 0 plus h. Now 0 plus more than 0. What is that? More than 0. The function is 0. So we will write here 0. Both are equal. LHL 0. RHL also 0. Now find f of 0. F of 0 is, the function is 0. When x is equals to 0, the function is 0. F of 0 is 0. Therefore, LHL is equals to RHL is equals to f of 0. So, you are getting equal here, LHL, RHL, f of 0. Next, so here we write f is continuous. F is continuous for x is equals to 0. For x is equals to 0, it is continuous. Next, case 3. Case 3 is what is the case 3? 0 less than x less than 1. So at 0 less than, so the next case 3, 0 less than x less than 1. So when it is 0 less than x less than 1, at that time the function is, so what is the function at the time? 0 less than x less than 1. So 0 less than x less than 1, the function is 0. So right here f of x is 0. This is constant number. Constant number. Therefore, f is continuous. Next, case 4. What is the case 4 for us? When x is equals to 1. So go for the next case 4. When, this is case 4. When x is equals to 1. How can we write? When we get equals, how we write it? LHL is equals to RHL is equals to f of 1. So, first we write LHL. Narendra. Who is Narendra? They sent one message to me. And again they deleted the message. Okay. LHL is equals to limit x tends to LHL of 1. 1 minus f of x. And I want to start from 0. Limit h tends to 0. F of x is replaced by 1 minus h. Now, limit h tends to 0. 1 minus means less than of 1. So, when it is less than 1, the function is 0. So, right here, 1 minus less than 1 is, we get 0 is the function. So, I will write 0 here. Why? Because there is no h for substitution. Directly we write the 0. LHL is 0. Next, RHL. RHL limit x tends to 1 plus f of x. Now, I will replace this 1 plus, that is h tends to 0. F of x is replaced by 1 plus h. Now, more than 1, what is the function? Greater than 1, now we will check. So, greater than 1, the function is 4x. So, write here 4x. 4. X means what? X is 1 plus h. 1 plus h. Now write h value in this function. 1 plus 0. This value is 4. Now both are not equals to. LHL I got 0 and RHL I got 4. Both are not equals to. LHL not equals to RHL. So next last case means f is not continuous. Both are not equals means f is not continuous for x is equals to 1 case. Next last case. What is the last case for us? X greater than 1. Go for the last case. 5. When x greater than 1. So what is the function? When x is greater than 1, the function is 4x. When x is greater than 1, the function is 4x. So write this one. F of x is equals to 4x. If you observe, this is polynomial. This is polynomial. When a function is polynomial, what about f? Is it continuous or not continuous? Yes, continuous. F is continuous for x greater than 1. Now, we will give the final conclusion. The final conclusion is, if you observe case 1, the case 1, it is continuous. Case 2, it is, case 2 is what? Also continuous. Next, case 3, continuous. Case 4, the case 4 is not continuous. And case 5, continuous. So, only at x is equals to 1, it is not continuous. We will write the final conclusion. Thus, f is continuous for all real numbers. X belongs to R except 1. So, except 1, it is continuous. Next question. The next question is question number 16. So, next question is question number 16. The 16th question is equals to minus 2, 2x, 2. So, minus 2, if x less than or is equal to minus 1. Next, if minus 1 less than x less than or equals to 1. Next, if x greater than 1. So, this is the question. Now, we will check continuity for this case. So, we will check continuity for different values of x. Write the different values first. When x less than minus 1 and x is equals to minus 1. In these two cases are there. One is x less than minus 1. Number 2, when x is equals to minus 1. And third case, minus 1 less than x less than or equals to, here I will take minus 1. When minus 1 less than x less than 1 I will take. The remaining x is equals to 1 in the next case I will write. So, when x is equals to 1. Last case, when x greater than 1. So, I got 5 cases. We will solve one by one these 5 cases. First case 1. Case 1 is when x less than minus 1. So when x is less than minus 1, the function is minus 2. So when it is less than minus 1, the function is minus 2. So f of x is equals to minus 2. If you observe, it is a constant number. So this is constant number. When function is constant, then f is continuous for x less than minus 1. Next, case 2. What is the case 2? When, we'll check. What is the case 2? Case 2 is x is equals to minus 1. So, x is equals to minus 1. Equals to k. How can we write? LHL is equals to RHL is equals to f of minus 1. Now, we will solve LHL. LHL is equals to limit x tends to minus 1 minus. We'll take left hand value of minus 1 is less of minus 1. That is minus 1 minus f of x. Now I want to replace these values. Limit h tends to 0. F of x is replaced by minus 1 minus h. Next, if it is minus 1 is less than of that, means we will select less than of minus 1. What is the function less than of minus 1? This is the less than of minus 1. Where we get this? In the first case. Less than of minus 1 is, the function is minus 2. I will write here minus 2. It is a constant number. No h in this. That's why directly I will write the number only. Minus 2. Therefore it is constant function. This is constant function. Therefore f is continuous or discontinuous? Yes, f is continuous. For we can do RHL also. Just we go up to LHL, go for RHL. If RHL gets same, then it is continuous. So RHL, how can we write the RHL? Limit x tends to minus 1 plus f of x. So limit, I will start from 0. h tends to 0, f of minus 1 plus h. Now we will identify the value more than minus 1. Minus 1 plus means more than minus 1. What is the function? Minus 1. More than minus 1 is, where we get? Here, more than minus 1. 2x. The function is 2x. So I will write here 2. X means what? The value is minus 1 plus h. Minus 1 plus h. Now write h value in this. So 2 into minus 1 plus 0. So we will get minus 2. What is LHL? I got minus 2. RHL minus 2. Next, f of, we have one more value. F of minus 1 also we need to find. So what is f of minus 1? So f of minus 1 means when x is equals to minus 1. X is equals to minus 1. The function is minus 2. If we check, we got LHL, RHL and f of minus 1 values are equal. Minus 2 only. Therefore, LHL is equals to RHL is equals to f of minus 1. Therefore, f is continuous for x is equals to minus 1. Next case. What is the next case? X is equals to minus 1 case over. Next, minus 1 less than x less than 1 case. So, case 3, minus 1 less than x less than 1 case. So at that time, what is the function? When it is minus 1 less than x less than 1, the function is 2x. So the function is, then which type of function it is? Polynomial or constant? It is polynomial. So it is polynomial function. Therefore, f is continuous for minus 1 less than x less than 1. Next, one more case. What is the next case? The next case is when x is equals to 1 plus 1. Minus 1 over we did. Now for plus 1. So how can we write again? Case 4 at x is equals to 1. How can we write equals to k? So LHL is equals to RHL is equals to f of 1. First I will take LHL. So how we write this LHL? LHL is equals to limit x tends to 1 minus f of x. So limit h tends to 0. I want to replace this. So f of x is replaced by 1 minus h. Now 1 minus means less than of 1. We will write the function when it is less than of 1. So where we get that? When it is less than 1, here we have the function. X is less than 1. So 2x. Here 2x means what? 1 minus h. Now write 0 in the h place. 2 into 1 minus 0, that is 2. LHL I got 2. Now I want to solve RHL. So RHL is equals to, how can we write this RHL? Limit x tends to 1 plus f of x. Now limit h tends to 0 f of 1 plus h. So 1 plus more than of 1. What is the function? More than 1, the function is 2. So if you observe here, x is more than 1, then function is 2. Right here 2 direct. So this is constant function. This is constant function. Therefore f is continuous. F is continuous for, so what I got? LHL. LHL got 2, RHL got 2. So that's why. Then I want to find f of 1 also. What is f of 1? When x is equals to 1, when x is equals to 1, the function is 2x. 2, x value how much? 1. 2. So LHL is equals to, write this one. LHL is equals to 2, RHL is equals to 2, and f of 1 also 2. So these three are equal. Therefore f is continuous for x is equals to 1. And what is the next case? The next case is x greater than 1. So when x greater than 1, last case, case 5, at x greater than 1, what is the function? When it is more than 1, the function is 2. So write the function as 2. This function is what? Constant function. So constant function. Therefore f is continuous. F is continuous. Now what is the final conclusion? Just we check. If we go for the case 1, the case 1 is continuous. And go for the case 2. Case 2 is also continuous. Then case 3 also continuous. Case 4 also continuous. Case 5 also continuous. Means in this question there is no discontinuity. So thus f is continuous for all real numbers. F is continuous for for all real numbers. So this is the question number 16. Next we will go for the 17th question. The 17th question is, see, we will check the 17th question. Find the relationship between A and B so that the function f defined by f of x is equals to ax plus 1 if x less than or equals to 3, bx plus 3 if x greater than 3. Now in this question, we need to find the relationship between a and b so that the function f is defined by. First, I will take these cases which are continued for different cases. The first case, when, if you observe here, x less than or equals to 3, x greater than 3. So here 3 repeated. I will take when x less than 3 case and when x is equals to 3 case and when x greater than 3 case. So first I will check for x less than 3. When x less than 3, f of x is, what is the f of x? When x less than 3, you just see the question, x is less than 3, the function is ax plus 1. Ax plus 1. So it is a polynomial function. F is continuous. F is continuous. And next, when x greater than 3, it is also polynomial. F is continuous. F of x is equals to bx plus 3. Therefore, f is continuous. Next, case 3. What is the case 3? When x is equals to 3. Now from this we will write the relationship between a and b. When x is equal to k, how can we write? LHL is equals to RHL is equals to f of 3. LHL. So how can we write LHL of 3? Limit x tends to 3 minus f of x. So I will start from 0. H tends to 0. F of 3 minus h. So 3 minus means less than of 3. What is the function? When x is less than 3, the function is ax plus 1. So limit h tends to 0. X means what? 3 minus h plus 1. Now write h value in this. So 3a plus 1. It is LHL. Then take RHL. So RHL is equals to, RHL means right hand limit of 3. Limit x tends to 3 plus f of x. Start with 0. Limit h tends to 0. F of 3 plus h. Now write the what is value of f of 3 plus h. when the x value more than 3 means greater than 3. Greater than 3, the function is bx plus 3. So right here bx means what? 3 plus h, bx plus 1. Now write h value in this. So we will get b into 3 plus 0 plus 1. Then 3b plus 1. It is RHL. And we equate this LHL and RHL. And if you find this, actually we have LHL is equals to RHL is equals to f of 3. If we find f of 3, what we get? When x is equals to 3, see here, when x equals to 3, what is the function? Ax plus 1 means what is x value here? 3. So 3a plus 1. Now equate LHL and RHL. LHL is equals to RHL. What is LHL we got? 3a plus 1. What is RHL we got? 3b plus 1. What is this? Bx plus 3. So here RHL is bx plus 3. This is 3. Here also 3. Now replace this value. 3a is equals to 3b plus 3 minus 1. So 3a is equals to 3b plus 2. Now we want the relation between a and b. So how can we write this one? A is equals to 3b by 3 plus 2 by 3. Now cancel 3. A is equals to b plus 2 by 3. This is the relationship between a and b. So this is the required answer. If you have any doubts, please comment. I hope you are understanding. Today's questions over. Tomorrow we will continue this. Thank you.